Okay, this video will walk you through doing the calculations in Microsoft Excel for lab number 1 in KNES 300. We won't have a kind of a walkthrough video of all the labs like this. It'll just be for this first lab exercise for a couple reasons. One, because we don't meet in person for this particular first lab exercise, so this video gives you some instructions to turn to or some help to turn to if you get stuck on actually doing these things. And two, because the main piece of software that we use in this lab exercise is the same one that you'll use in all of your lab exercise, and that's Microsoft Excel. And you may have used that before. You may have some experience with it. Some of you may have a lot of experience with it, but some of you may have no experience with it, or maybe if you do have some experience, it's been a while since you've used it. And so this lab exercise will have a little bit of biomechanics in it, but not a whole lot. We really haven't taught you a great deal of biomechanics yet. But the more important thing to take away from this first lab exercise is some experience and familiarity with doing the things in Excel that we will ask you to do for all the lab exercises in the class, namely performing calculations and making graphs, and also just some general experience in taking descriptions and statements of problems from the lab handbook and transcribing them into Excel to actually solve those problems in practice, which is a valuable skill to learn and one of the key things that you should hopefully get out of this class. Some ability and some skill in applied math, reading about a formula in a reference somewhere and actually applying it and using it and solving it in practice in an actual problem in this class, of course, in biomechanics problems. Okay, I'm going to close my photo booth app here because those take up a ton of memory. And you're going to want to have two files open here when you are following along on this video. You're going to want to have your lab handbook open, and you're going to want to have your lab 1 spreadsheet open. And on my lab handbook, I can navigate down to exercise and report for lab 1 for my instructions. And there's 4 problems here to solve for this first lab exercise. And those are organized on the spreadsheet with the first 3, problems 1 through 3 in this first sheet, and then the last one, problem 4, on this second sheet. And on both of those sheets, anywhere where you see a yellow box is where you either need to enter some information, in the case of these top 3, or enter a calculation in the case of every other box on either one of those sheets. So my name is Ross. I don't have a lab section, I'm the instructor, but let's suppose I was in section 1, and my TA in section 1 would be Sam Schneider. Okay, so for problem 1, it asked me to calculate. If I go to my instructions, we have a right triangle, and we're given the length of the hypotenuse is 4.8, and that one of the internal angles is 29 degrees, and we're asked to determine the length of the other 2 sides of the triangle, the side opposite that 29-degree angle and the side adjacent that 29-degree angle, as well as the value of the other third unknown internal angle. A pretty basic trigonometry problem, but again, just like it might have been a while since you used Microsoft Excel, it might have been a while since you did some basic trig. And I'm a visual person. I like to see diagrams of what I'm working with and make diagrams of what I'm working with. So let's make a diagram here. And I had one already drawn because I was practicing before I made this video, but I find it helpful to see the diagram made from scratch, not just look at the finished thing. So let's start from scratch. So let's draw a right triangle here. And it's a triangle because it's got 3 sides. Oh, didn't quite make it there. There we go. Okay, and we're told this is not just any triangle, this is a right triangle. And what makes it a right triangle? Well, that means that one of the angles in the triangle is exactly equal to 90 degrees. And that's this one down here. We can draw a little box there indicating that it's 90 degrees. And then we're also told that one of these other 2 internal angles, doesn't matter which one, so I'll just pick this one down here, has a value of 29 degrees. So I'll label that on there, 29. And then we've got this third angle up here, which we don't know. So I'm just going to give it a symbol here, theta, indicating that we know this is an angle, we know it exists, but we don't know the value of it, so we'll just give it a symbol rather than a number. And we're also told that the length of the hypotenuse here, which is the longest side of the triangle, opposite this 90-degree angle, has a length of 4.8. Okay, so given that information, given the length of the hypotenuse, the size of one internal angle, and the knowledge that this is a right triangle, we're asked to calculate the value of this other angle and the length of these other two sides. And so how can I do that? There's a few different ways you could do these calculations in different orders and with different formulas that would all arrive at the same result. It's one of those type of problems. And you'll see several problems like that in this class where there's not necessarily just one way to do it. And you'll see problems where there's also not necessarily even one single correct answer to it. It could be several correct answers. This particular problem is one that indeed has a unique singular correct answer for each thing that it's asking you to calculate, but there's different pathways you could take to get to all of those answers. There are different ways you could do this. The way that I'll demonstrate it here in the video is just the way that seems quickest and most intuitive to me, but there are other ways you could do this and arrive at the same results that I'll arrive at here. So first thing I'm going to do is I'm going to calculate this unknown third angle in here. And how do I do that? On the merit of being a triangle here, which is a shape that has three sides, 1, 2, 3, and three internal angles from the connections of those sides, angle 1, angle 2, angle 3. If I take the values of all three of those angles and add them up, they geometrically have to add up to a total of 180 degrees. Okay? So if I take this 29 degrees, and this 90 degrees, and this unknown angle theta here, if I add, if I add all three of those angles up, they've got to sum up to a total of 180 degrees. Okay. So this is an algebraic equation here, and it's one equation, and it's got one unknown quantity in it, theta. Okay. So one equation, it's got one unknown. I can solve that one equation for that one unknown thing. If I had two equations, I could solve them together for two unknown things. Three equations, I could solve for three unknown things, etc., etc. So that's a general rule in algebra. If you have a system of a certain number of equations, you can solve for that same number of unknown things combined across all those equations as a set of equations. So I've got one equation here, one unknown in that equation. How do I solve for that unknown? Well, I want to get theta here isolated by itself on the left-hand side of this equals sign. And how do I do that? Well, I subtract 90 from both sides, and I subtract 29 from both sides. And so that would look like this, where I'd have theta equals 180 minus 90 minus 29 degrees, degrees, degrees. Always include the units, never omit the units. Okay, so theta equals 180 minus 90 minus 29. You could calculate the result of those subtractions there in a calculator or just in your head, and you would get that theta equals 61 degrees. So let's go back to my spreadsheet. And I'm asked to enter my other internal angle here in cell B10, so I click on B10. And I could just punch in the number 61 there and hit return, and then I've got 61 there. But that's not what we want you to do on this first lab. The purpose, or the main purpose of this lab, isn't just to do these calculations in general. It's to learn how to do calculations like this in Microsoft Excel specifically. So I don't want you to calculate 61 here somewhere else and then copy that 61 over to this spreadsheet. I want you to do the calculation of the 61 in the spreadsheet. And how do you do that? Well, rather than entering the number in there, you click on the cell where you want to do the calculation, and you enter in the calculation you want it to do. And how do I get Excel to understand that I want you to do a calculation, not just display the result? Well, if I go to my cell, and if I just enter in, okay, 180 minus 90 minus 29 and push return, I don't get anything. It just shows exactly what I typed in there. So let's delete that out. How do I get it to do that calculation? I click on the cell and I punch in an equals sign. Okay? And that equals sign is the trigger to get Excel to say, oh, you don't want me to just display what you're doing here. You want me to calculate everything that comes after this equal sign and display the result of that calculation there. Okay, so that's what the equal sign is indicating. If you want Excel to do a calculation, you push the equals sign in the cell that you want the calculation to appear in, and then type in what you want it to calculate. Okay, so I click on cell B10, and I do equals 180 minus 90 minus 29, and then return. And this time with the equal sign in there, it actually did that calculation and calculated the result, which was the 61 degrees. So you could think of this as, if I go back to my diagram here, I copied everything after the equal sign, or on the right-hand side of the equal sign, including the equal sign itself, into, wrong one, into this cell here, and Excel performed that calculation. Okay, we're also asked to calculate the adjacent side of the triangle and the opposite side of the triangle. And this will give us some practice in using trigonometric functions in Microsoft Excel. And let's go back to my diagram. And let's clear some space down here. Okay. So I've got my right triangle here. The long side is my hypotenuse, and then I've got these two shorter sides. Okay? One of these sides is called the adjacent side, and one of them is called the opposite side. Now, which one's opposite, which one's adjacent? Those terms, opposite and adjacent, are in reference to a particular internal angle of this triangle. So which side's the opposite side, which side's the adjacent side? You need more information to specify that. Opposite of what, adjacent of what. This problem, when it's saying the opposite side and the adjacent side, is asking for the side of the triangle opposite this 29-degree angle and the side of the triangle adjacent to this 29-degree angle. Okay? So now with that angle specified there, which side is the opposite side, which side is the adjacent side? The adjacent side, you can think of adjacent as being a fancy word for touches or is connected to. So this horizontal side here is adjacent to this 29-degree angle because when I draw that angle, the angle touches that side, or it's adjacent to that side. If I contrast this with my other side here, that vertical side, that side is opposite of this internal angle, this 29 degrees, because it doesn't touch that angle. Okay? So the angle touches the adjacent side, it doesn't touch the opposite side. And this is also a good time to demonstrate how which side is adjacent and which side is opposite is not like a fixed thing. Like this vertical side is not always the opposite side and this horizontal side is not always the adjacent side. They have those particular definitions because I'm referring to this specific 29-degree angle here. If I was saying which side is opposite this 61-degree angle here, that would be this long horizontal side because that side doesn't touch this angle, and the adjacent side would be this shorter vertical side because that side does touch that angle. Okay. So the horizontal side is opposite this 61-degree angle, but it's adjacent to this 29-degree angle. Okay, so those terms opposite and adjacent, don't get used to like automatically conflating those with like, oh, the opposite side's the vertical side and the adjacent side's the horizontal side. That'll often be the case, but opposite means opposite some particular angle in a right triangle, and adjacent means adjacent to some particular angle in a right triangle. It doesn't automatically mean horizontal and vertical specifically. Okay, if I know the angle, which I do, and I know the length of the hypotenuse, which I do, then the adjacent side, that horizontal side in this case, is the length of the hypotenuse times the cosine of that angle. And the opposite side, the length of that opposite side, is the length of the hypotenuse times the sine of that angle. Okay, so let's just give these some labels here. Let's call this horizontal side length x, and this vertical side length y. X would be the 4.8 times the cosine of 29 degrees. I'm drawing these with the trackpad. Sorry if I'm a little slow and sloppy here. And the y side length would be the 4.8 times the sine of the 29 degrees. And to, again, perform those calculations in Microsoft Excel, I basically copy everything on the right-hand side, including the equals sign itself, into Microsoft Excel here. But it's a little bit more nuanced in how we actually do that in practice. So let's take a look at that. So my adjacent side, which I'm going to enter in cell B11 here, the calculation for that, I do equals, and then I could type in 4.8 times cosine 29 degrees. But I would say a better way to do it is, let's clear that out. And let's do equals, and then click on the cell that has the hypotenuse in it, which is B8, times the cosine, and then left parenthesis, and click on the cell that has the internal angle in it. Okay. Why is it better to reference those cells rather than to manually enter the value? It's not really. You'd get the same result either way. 4.8's 4.8, 29's 29. Doesn't matter if you click on it or type it in. But it's a more general way of doing these calculations. It's a way of defining a calculation relative to the contents of a particular cell. So here I'm saying I want you to take the hypotenuse times the cosine of the internal angle. Okay. The hypotenuse could be any particular length. It could be any particular angle. Doesn't really matter what. It's still going to do the calculation. Okay, so I enter that out and I get some particular result. If I then decided, oh, whoops, I made a mistake here. Let's suppose the hypotenuse was actually 5.8. Then it automatically updated my calculation down there because it's defined relative to the contents of that cell, not defined for a specific value entered into that calculation like 4.8. But 4.8 wasn't in fact correct, so let's enter that back. Okay, I got kind of a funny result here, right? I got a negative length. That physically doesn't make a lot of sense. I actually made a mistake in my calculation here. I did the hypotenuse length times the cosine of that internal angle, which is geometrically the correct definition here for my adjacent side length. But problem is I entered my internal angle, my argument for this cosine function in the parentheses there, I entered it with the wrong units. Okay. When you are doing calculations involving trigonometric functions like sine and cosine and tangent primarily, generally speaking, most pieces of software and most calculators that you use those functions with will be expecting you to enter in the arguments to them, like the angle that you enter in here, the cosine of what specifically. The argument that you enter in there for that function to operate on, it'll be expecting that angle to be entered in units of radians, not in units of degrees. Okay, so you won't get the correct or the mechanically correct result unless you enter the argument for that trigonometric function, in this case the cosine function, with units of radians. And here I've got it entered in units of degrees, and that's why I got an answer that seems a little screwy there, a negative side length. So let's start over here. And I'm going to click on my cell B11, and I'm going to say that equals the hypotenuse times the cosine of the 29 degrees, but I need to convert that 29 degrees from degrees to radians. And how do I do that? I take the degrees and I multiply by the number pi, which has a value of about 3.1416, and I divide by 180, and then close it out with the right parenthesis. And there I got something that makes a little bit more sense. A positive angle, or a positive side length that's less than my 4.8 there. If you want to be real exact on what pi is, you can, instead of typing in 3.14159 or 16 or whatever, you can enter the word pi and then left parenthesis, right parenthesis. Okay. Why do you have to do the left parenthesis, right parenthesis after pi? Why can't you just do pi? I don't know. That's just an Excel thing. That's just the way Excel wants you to indicate, oh, you're using the quantity pi here. Okay. Then push return, and you get about the same thing, but not exactly the same thing. I like doing it that way because then I don't have to remember what pi is or decide what pi is out to a certain number of digits. I can just say, hey, I'm working with pi here. Okay, so that's my adjacent side length. I'll do a similar thing for my opposite side length. That's going to be equal to my hypotenuse times the sine of the 29 degrees. And then I multiply that 29 by pi and divide by 180. Close it out with a right parenthesis. And 2.32, yada yada. Okay. There's a little passage here on significant digits in the lab handbook. If you haven't read that already, take a look at it. It's up here towards the end of the first section here in the lab handbook. Right there, section 1.5 on significant digits. Not something I'm real strict on in this class, but something that I'd like you to pay attention to and demonstrate that you're thinking about. So you're not going to lose points if you include, like, say, 2 significant digits when technically speaking you only should have included 1, or if you include 1 and technically it should have been 2. Little mistakes like that you're not really going to get penalized for in terms of your grade in the class. It's not really what this class is about, learning those type of things. I would like you to indicate, though, that you're following some basic rules and at least thinking about these things. Okay? For example, a good basic rule is use the same number of significant digits as the numbers that you are performing your calculations on. Okay, so I was given, for example, my one internal angle of 29.0 degrees. It's got one significant decimal place there after the decimal point. So I should present my other angle that I calculated there from that 29 degrees also with one significant digit after that decimal point. Okay. I could go here and type in 61.0, but then Excel tries to outsmart me and says, oh, you don't need that 0.0, I'm not going to show it. That also cleared out my calculation there, which I don't want to do. So let's undo that. So how can I get this to show me one decimal place instead of no decimal places? Well, I click on the cell, and then I go up to Format, and do Format Cells, and then click on Number under Category, and then I can tell it how many decimal places I want it to show. So since I have 29.0 with one decimal place, let's also make this 61.0 with one decimal place. And then there we're good. And let's do the same thing here for my side lengths. My hypotenuse length that I was calculating these side lengths from has one decimal place, and so let's revise my numbers here to show them both with one decimal place. So I'll select both of these cells, and I will go to Format Cells and Number, and change them down to one decimal place. And then I've got 4.2 instead of 4.285557 or whatever, and 2.3 instead of 2.327, yada, yada, yada. Okay, so problem 1 there, showing you how to do calculations in Excel in general, how to work with functions, how to deal with converting degrees to radians, and how to set the number of significant digits after the decimal place that you show. There's actually going to be 4 videos here to keep these to kind of a manageable length. I'm going to do one separate video for each one of these 4 problems, and so that's the end of problem 1, and then the next video will walk us through problem 2.